So you remember, exponential growth occurs when you have a function of the equation y is y naught e to the kt. And when k is positive, you have growth, and when k is negative, you have decay. So here is the growth of carbon dioxide over time. Find a different exponential model using the data for 2000 and 2175. Let the year 2000 correspond to t equals 0. So we're going to use two of these data points. And we want it to take the form y is y naught e to the kt. So we're going to need to find y and k. Now, the year 2000 corresponds to t equals 0, and 2175 corresponds to t equals 175. Since y naught is the initial amount, y naught is 375 when t is 0. So the equation becomes y is 375 e to the kt. So now we need to find another point. So I know when t is 175, y is 1090. Substitute these in. 1090 goes in for y. The 375 is already there. T is 175. So now we need to solve for k. So we're going to divide by 375 and take the natural log of both sides, and then divide by 175. So we get k is equal to 0.00610. So the model of my equation is y is equal to 375 e to the 0.00610 times t. Use the model to estimate when the future levels of carbon dioxide will triple from the 1951 level of 2,000 parts per million. So we're going to let y equal 3 times 280 because we want it to triple, and so that's 840. So we're going to use that and solve for t. So 840 is equal to 375 e to the 0.00610 t. Divide by 375, take the natural log of both sides, divide by 0.00610. So t is 132. So since t equals 0 corresponds to the year 2000, t equal 132 corresponds to the year 2132. So the carbon dioxide levels will triple from the 51 levels in 2032. How long will it take for the money in an account that is compounded continuously at 4.25% to double? Well, we're going to go to our compounding continuously formula. A is PE to the RT. And we want to know when it's going to double. So we're going to want to know when A is twice the initial amount. And R is 4.25. So 2P is equal to P, e to the 0.25T. So 2 is equal to e to the 0.425T, natural log of both sides. So t is natural log of 2 divided by 0.425 for about 16.3 years. Now, the projected world population in billions of people T years after 2010 is given by the function f of t is 6.947 e to the 0.00745 t. What is going to be the world's population at the end of 2020? All right, so the year 2020 corresponds to t equals 10. So f of t is 6.947 e to the 0.00745 times 10, which is about 7.484. So the world population will be about 7.484 billion at the end of 2020. In what year will the world population reach 8 billion? So we're going to let f of t equal 8, and then we're going to solve for t. So we're going to divide by 6.947, take the natural log of both sides, divide by 0.00745, and we get t is about 18.9. So since t equals 0 corresponds to the year 2010, adding 18 to it tells us the world population should reach 8 billion during the year 2028. Now, suppose 800 grams of radioactive substance are present initially, and 2.5 years later, only 400 grams remain. Determine the exponential function that models the decay. So we're going to start with the exponential equation, y is y naught e to the kt. And the first data point is y is 800 when t is 0. So it tells me my initial amount is 800. So the equation is y is 800 e to the kt. So I'm going to go to the next equation, the next data point, which is 400 grams are present when t is 2.5. So we're going to substitute those values in and solve for k. So 400 is equal to 800 e to the 2.5k. Divide by 800, so I have 1/2 log of both sides and divide by 2.5. So k is minus 0.277. So the exponential equation is y is equal to 800 e to the minus 0.277t. Suppose 800 grams of a radioactive substance are present and initially, and 2.5 years later, only 400 grams remain. How much will be present after 4 years? Well, we are going to use our equation and substitute in t equals 4, and we get 264.2 grams are left after 4 years. Now, suppose that a skeleton of a woman who lived in the classical Greek period was discovered in 2005. Carbon-14 testing at the time determined that the skeleton contained 3/4 of the carbon-14 of a living woman of the same size. We're going to estimate what year she died in. So the amount of carbon present after t years is given by y is y naught e to the minus 0.00012116t. Now, I don't expect you to know this equation. So let y equals 3/4 y naught and solve for t. So when I substitute in, I'm going to divide through by y naught. So 3/4 is e to the minus blob. Take the natural log of both sides. So the natural log of 3/4 is minus 0.000126t. Divide by your coefficient. So t is about 2,365.8. So the woman died about 2,366 years before 2005, or in 361 BC. Now, Newton's law of cooling says that the rate at which a body cools is proportional to the difference C in temperature between the body and the environment around it. The temperature of the body at the time T, in approximate units after being introduced to an environment having a constant temperature T naught is F of T, is T naught plus C e to the minus KT, where C and K are constants. Now, Newton's law of cooling also applies to warming. So, if Mary took a leg of lamb out of a refrigerator, which is set at 34 degrees, and it places it in her oven, which she has preheated to 350, after 1 hour, her meat thermometer is registered at 70 degrees F. Write an equation of the data. Well, from the data, we know at T equals 0, F of 0 is 34, because the lamb is the temperature of the refrigerator. And T naught is 350. When T is 1, F of 1 is 70. So we're going to solve for C. So we're going to have 34 is equal to 350 plus C. So C is minus 316. Now I'm going to solve for K. So F of 1 is 350 minus 316e to the minus K. Putting in 70, and I solve. I take the natural log of both sides. I get K is about 0.1210. So the equation is 350 minus 31e to the minus 0.121t. If I wanted to find the temperature 90 minutes after the leg was placed into the oven, it says T is measured in hours. I have to convert 90 minutes to 1.5 hours. So putting in 1.5, I get about 86.5. So after 90 minutes, the temperature is going to be 86.5 F. Now, she wants to serve her leg of lamb rear, which requires the internal temperature of 145. How long should she put it in the oven for? So we're going to set F of T equals 145, and we're going to solve. Take the natural log of both sides. So I'm going to get T to be about 3.576. So the meat temperature will be 145 after about 3 hours and 35 minutes of cooking.